Have you ever seen a river of life? Not a big roaring river, but a tiny, shallow stream, just a few millimeters deep, flowing quietly and constantly. This moving current of minerals is the heart of one of the most elegant systems in hydroponics, the nutrient film technique, or NFT. Unlike systems that flood roots or drown them in deep reservoirs, NFT sends a thin, continuous film of nutrient solution flowing gently along the base of a channel. The name says it all. A thin film of water passes across the roots. It's not a pool, it's not a bath, just a flowing layer of life. Here's how it works. Plants sit in small openings along a slightly sloped channel. Their roots grow downward and spread along the bottom, right where the nutrient solution flows past them. This water is pumped from a reservoir at the lower end of the system up to the higher end. Gravity then carries it back down through the channels. When it reaches the end, it returns to the reservoir and the cycle begins all over again. It's a perfect loop, a constant circulation of water, minerals, and oxygen. To understand why NFT works so well, let's think about what roots really need. They need nutrients dissolved in water. But just as importantly, they need oxygen. In deep water systems, you have to actively bubble oxygen into the reservoir. But in NFT, oxygen is naturally available because a large part of the root mass is exposed to the air inside the channel. The thin film of nutrient solution weights the roots without completely submerging them. So the upper part of the root stays in contact with the air, allowing oxygen to be absorbed naturally. This delicate balance between moisture and air is the secret to NFT's success. The design itself is beautifully straightforward. You have a reservoir to hold the nutrient solution, a submersible pump to lift it into distribution tubing, and one or more grow channels which are slightly angled downward. At the end of each channel, the solution drains right back into the reservoir. Plants are supported in net pots or special collars that are inserted into holes along the top of the channel. The growing medium is minimal, often just enough to stabilize the young plants. As they mature, their roots fill the channel, forming a dense mat along the bottom, like a living carpet that the nutrient solution flows across. One of the biggest advantages of nutrient film technique is its incredible efficiency. Because the nutrient layer is so thin, very little water is needed at any given moment. The system recirculates the same solution over and over, which minimizes waste and makes NFT highly water efficient compared to traditional farming. It also provides excellent nutrient consistency. Since the solution is always moving, nutrients are evenly distributed to every plant in the system. However, that constant movement is both a strength and a weakness. If the pump stops for any reason, that thin film of water disappears very quickly. The roots can dry out much faster than they would in a deeper water system. For this reason, NFT systems depend heavily on a reliable power source and consistent monitoring. A backup power supply is a really smart investment for any serious NFT grower. Despite this, NFT has become one of the most widely used systems in commercial hydroponics, especially for leafy greens. Crops like lettuce, arugula, spinach, and all sorts of herbs absolutely thrive in NFT channels. These plants have relatively small root systems and short growth cycles, making them a perfect match for the shallow channels and continuous flow. In large commercial operations, you'll see long, straight rows of NFT channels stretching across vast greenhouse floors. They might even be arranged in vertical tiers, maximizing every square foot of growing space. Plants grow in perfectly uniform lines, all evenly spaced and receiving the exact same flow of nutrients. This allows growers to control harvest cycles with incredible precision. New seedlings are transplanted into the channels on a regular schedule, ensuring a continuous, year-round production of fresh produce. The slope of the channel is a critical part of the design. If the angle is too steep, water flows by too quickly, and the roots might not have enough time to absorb the nutrients they need. If the angle is too shallow, water can start to pool and create stagnant zones, which can lead to root problems. Most systems use a gentle slope of about 1 to 3%. This creates a smooth, consistent flow without causing any turbulence. Channel width also matters. If the channels are too narrow, the mature roots can eventually clog the flow of water. If they're too wide, the nutrient film might spread too thin or become uneven. Precision in the design is key to maintaining that perfect balance between hydration and oxygenation for the roots. Managing the nutrients in an NFT system is similar to other hydroponic methods. Growers constantly monitor the pH to keep it within the ideal range. They also measure the electrical conductivity, or EC, to make sure the nutrient concentration is just right for the plant's current stage of growth. Because NFT systems hold a relatively small volume of water compared to deep water culture, the nutrient levels can change quickly as the plants absorb minerals. So, regular monitoring is absolutely essential. Temperature control is another important factor. A warm nutrient solution holds less dissolved oxygen and can create a welcoming environment for harmful pathogens. And of course, cleanliness is critical, since the nutrient solution circulates through the entire system. Any contamination can spread to all the plants very quickly. It's important to thoroughly clean the channels between each growing cycle. And the pumps and tubing require periodic maintenance to keep everything running smoothly. Despite these considerations, NFT offers remarkable scalability. You can build a small home system that fits on a balcony or against a wall, with a single pump supporting a few short channels for your kitchen herbs and lettuce. On the other end of the spectrum, at the industrial scale, the climate is regulated, light levels are optimized, and harvest schedules are perfectly synchronized. This makes NFT particularly attractive for urban vertical farms. By stacking layers of channels, these farms can produce huge volumes of food in a relatively small footprint. The lightweight design of NFT channels allows them to be mounted on racks without needing a lot of heavy-duty structural support. Another huge benefit of NFT is rapid growth. With constant, uninterrupted access to nutrients and oxygen, plants often mature much faster than they would in soil. The uniform conditions across the entire system also promote consistent size and quality. This consistency is highly valuable in commercial markets. However, NFT isn't the perfect system for every type of crop. Large fruiting plants like tomatoes and cucumbers develop very extensive root systems and require more structural support than a simple channel can provide. While they can be grown in modified NFT systems, NFT truly excels with lightweight, fast-growing crops. It's a system built entirely for flow, the flow of water, the flow of nutrients, and the flow of production. In many ways, nutrient film technique reflects a broader principle in modern agriculture. Instead of overwhelming roots with excess water, it provides exactly what is needed in a continuous, gentle stream. It's minimal, but it's constant. As our global population grows and agricultural land faces increasing pressure, systems like NFT offer a clear path toward more efficient and controlled food production. They dramatically reduce water use. They eliminate our dependency on soil. And they allow us to farm in places once considered completely unsuitable for cultivation inside warehouses, on city rooftops, and in other dense urban environments. Those images of NFT channels glowing under LED lights have become symbols of modern agriculture. The rows of bright green leaves suspended above a flowing stream of nutrients. It's no longer bound to seasons or soil, but instead guided by balance, precision, and circulation. At its core, nutrient film technique is profoundly simple: a pump, a slope, and a thin moving layer of life. The roots touch the stream, the air surrounds them, and the leaves reach upward toward the light. And in that steady, quiet current, growth unfolds continuously and beautifully. Thanks for watching, and don't forget to follow for more.